Hello, and thanks for downloading this latest IoT Central podcast. This is Bill Voorhees, your host. I'm a contributing editor with IoT Central and also Chief Data Scientist for Data Magnum. Today's podcast is sponsored by TIBCO. We very much appreciate TIBCO's support for the IoT Central community, and we're honored to have them sponsoring our event today. Now, this podcast will be about 15 minutes long, and we have one speaker who I'll introduce in just a minute. And today's talk is entitled Equipment Monitoring, Surveillance, and the Industrial Internet. Our speaker is Michael O'Connell, who is the Chief Analytics Officer at TIBCO. Now, Michael develops analytic solutions across a number of industries, including financial services, energy, life sciences, consumer goods and retail, telco, and media networks. He's been working on statistical software applications for the past 20 years, and has published more than 50 papers and several software packages on statistical methods. Now, Michael holds his PhD in statistics from North Carolina State University and is currently an adjunct professor of statistics there. So, Michael, thanks for being with us today. Now, I understand that you're going to expand on the theme you've been developing recently about the uses of IoT in the energy sector. Now, as you've pointed out, energy producers are rich with sensor data that can be analyzed both visually and with machine learning to predict equipment stoppages in real time. So why don't you share with us your thoughts and experiences about using streaming sensor data with the TIBCO platform to optimize production and energy and other industries as well. Michael?
Absolutely. Yeah, look, at TIBCO, we work in multiple industries to monitor and optimize industrial equipment operations. You know, in the energy sector, as you mentioned, the equipment often transmits readings on parameters like pump intake pressures or current, temperature, and accumulated data can be analyzed to produce models that correlate parameter changes to problems in the equipment. Those models can be deployed into operations, and new sensor data can be scored against the models to flag potential issues for investigation before the production or the drilling, is affected. And this applies in general across all sorts of industrial equipment. In the manufacturing sector, we work on execution and process control, fault detection, predictive maintenance of the equipment, as well as yield optimization, product analysis, performance and quality analytics, anomaly detection, yield optimization, and so on. So in both these scenarios, you've got historical data where on the accumulated data, you figure out what are the patterns and parameters that are leading indicators of an anomaly or an equipment situation or a yield or a production downturn. And then you can put those models and rules into production on real-time data to get out ahead of any problem that might occur. So I mentioned some of the things in the energy sector, production surveillance, of course. We also get into real-time drilling, working closely with a customer there right now, Anadarko, on real-time drilling. We get into industrial machinery, where we work with companies like GE in the aviation or healthcare unit, equipment out there for surveillance, monitoring, predictive maintenance. We work in the connected vehicles area. We have a partnership with the Mercedes F1 team right now, where we're doing a lot on the configuration of the car and the optimal operations, of the car in the races. So those ideas about that we discussed firstly in the energy sector, for production surveillance in oil and gas, for drilling optimization, apply across a variety of industries, and we're active, in all those industries. So I thought I would just dig in a little bit to a couple of the use cases and companies that we work with. In the energy sector right now, there's the uptick in oil prices has led to quite a lot more activity on the drilling front, and the IoT platform that we have out there in that area was recently discussed by Anadarko at our Energy Forum, and it includes both IoT edge analytics for equipment monitoring and for optimizing the drilling operation, but also central componentry for looking across different rigs for comparing productivity, performance across the rigs. And all of this is powered by this internal data science and machine learning capabilities that are able to look at some of the historical data and guide the real-time operations. So some of the ways we do this, and this applies to all those other examples I mentioned, high-tech manufacturing and industrial equipment, machinery, connected vehicles, is firstly the notion of having good set of data connectors. So in the TIBCO Connected Intelligence portfolio, we've got connectors down into specialized sources. So in the energy sector for drilling, we're talking about WITSO or WITSML type applications, being able to bring that data in, both to the TIBCO data science tooling for looking at historical data, as well as to the real-time or event processing data coming off the drilling equipment, and bring that data in and write it back out for the monitoring. So it all starts with the connectors, and then getting in on top of that with the analytics. So some of the things we do in the real-time drilling is firstly just understanding the state that the drill is in. So every second, what is the state? Is it sliding, or is it rotating, or is it the trip in, trip out? Understanding the state is the first step, and then being able to figure out the directional calculations, where the drill path is going, understanding torque and drag, for example, and then figuring out what is the best pattern from the historical data, applying that to get the best path to match the original planned path. And then if you go off track, how to get it back, on track, that trajectory correction. It's kind of like, in a GPS navigation system in your car, you have an original path, and then if you go off track, how do you get back to the optimal path? So that sort of a thing. So all of those use cases in the drilling example, there's a combination of being able to do the analysis locally on the edge, out at the rig, and to make those corrections, in real time during the drilling operation. But there's also back at the ranch, so to speak, keeping an eye on all of the drilling operations and the equipment sensor data coming in to all of them into a central control facility. Now that model of central control facility, also works very well for production surveillance. So if you're an oil and gas operator and you have lots of wells out there that you're monitoring, getting that data coming through on pump intake pressure or current or downhole pressure or temperature, and matching those combinations of data to anomalies that you've detected on the historical data, and figuring out when a well is trending in a direction where there might be a production stoppage or an issue. That is a sort of command and control central to edge, core to edge type of application. And so we're able to detect, if there's a sort of pressure buildup in the downhole or some kind of blockage, which would ordinarily lead to the well shutting off. A lot of these wells are driven by artificial lift systems. You have to pump the well out of the ground, and if those conditions start to act up, then you want to be able to fix them. So that ability to monitor like literally thousands of wells and the production coming off them, keeping that optimal, avoiding non-productive time, is of incredible value. So, that's kind of some of the energy sector applications. In the more industrial machinery set of applications, being able to monitor and service equipment, whether it's in the healthcare sector, a hospital type equipment, or whether it's in the aviation world, monitoring the health of the airlines in flight and also as they land, to keep maintenance efficient and optimal. Those sort of things are also in the same realm, where you're looking at historical data to understand potential anomalies or areas for optimization, and applying that to the real-time data stream, and refreshing that on the time schedule that makes sense. Maybe it's every second, maybe it's every minute, maybe it's every hour, maybe it's once a day. That type of flexibility to do event-based analysis and notifications on the granularity of the data. So the way we do that, let me now segue across into into the TIBCO Connected Intelligence portfolio and how we apply those analytics, on the historical data and then on the event stream. It's really this two-speed architecture that we have in the Connected Intelligence portfolio, where we're able to look at the historical data and with sophisticated visual analytics and data science tooling to find the insights and patterns that are leading indicators of the potential problem or the opportunity. So the data science tooling, Spotfire Data Science is a product that goes down into the data lake, into the database on very big data, allows you to prepare that data at scale, run machine learning models, and then manage those models out into a production deployment. That whole life cycle of data preparation at scale on big data, the machine learning modeling, the deployment of the models out into a container-based, web-based environment, and then managing the different versions of the models, doing champion-challenger bake-offs, that sort of thing, and doing that in the cloud that life cycle is part of the secret sauce of the TIBCO platform. Not many folks can do all the whole life cycle of access and data prep, modeling, deployment, and operational infrastructure and continuous analytics. And so the data science part of that, as I mentioned, has a strong set of data prep componentry, as well as a number of interfaces. So there's a visual composition interface for machine learning. There's a notebook interface. Like I say, all of that runs down in the database or in the data lake at scale. And then there's a visual analytic application, Spotfire, that allows you to either bring data into memory or to analyze it down in the database and get up some kind of set of notifications, dashboards for that alert from the issues that you've identified with the data science tooling. And then the deployment part, there's a number of scenarios there for event processing. We have some products there. Streambase is our JVM-based product for doing real-time math on event streams. And then Flogo is our lightweight environment, open source, written in Golang, that allows low-code, quick production of live applications, in the Go environment. And that the componentry that we have on the data science side works out and maps very well to the Flogo and the Streambase and business events products that run on the event stream. So it's a point-and-click operation to take your model that you've developed in Spotfire Data Science and push that across in Go code to run on an edge device. Now, with Flogo, that edge device can be incredibly lightweight. So we're, putting out, let's say, a TensorFlow model or a Spotfire Data Science model out into an edge device. The edge device can be disconnected, or it can be running serverless, in the cloud. And that sort of deployment is it's incredibly productive in the sense that you can get a score back from a predictive model in milliseconds, which really saves costs if you're deploying that serverless on AWS. Or it allows you to function in a offline intermittent connectivity environment in an actual device. So maybe you have a device that is keeping track of containers on a ship that's running a shipping operation, and you're keeping track of temperature or other conditions that you need when you're transporting the product. And that is all that intelligence of the of tracking and the trending and time progression of the temperature, pressure, and so on can all happen locally on the container in that case, without having to come back to a central cloud compute environment. So there's a lot of flexibility here. Some of the guiding principles of the Connected Intelligence portfolio are no device is too small or too far away is one principle, and that really works well in this area of disconnected, intermittently connected devices. So when you have the full infrastructure available, then you can stand up whatever you want, and in that case, we've got the full, we've got a live data mart for keeping track of the incoming sensor data. We have connectors to event streams that are doing math on sliding windows. We have the notion of live apps that display event stream data, and with the ability to alert and send notifications when a potential situation is about to arise. And one part that's often overlooked is the data prep piece. So at TIBCO, our philosophy is to give the data prep capabilities to the different environments, to the personas that operate the software in those environments, to make the software be able to prepare the data. A lot of the effort is in data prep, and so with Spotfire Data Science, a lot of the operators are to prepare the data on the historical side, and then out in Flogo and Streambase, more at the edge. We have a lot of capability in those products also to take the incoming event stream and process that to be ready for the application of the analytic insight or the model. So another principle of the connected intelligence portfolio is this idea of better together. And we have the philosophy that the products have deep functionality. They're easy to use in a standalone sense, but they also interlock and intercommunicate. They're loosely coupled, but they're tightly integrated. So this idea of doing data science on the historical data and publishing out the model for use in the real-time stream is a key component as well. So I hope that gives you an overall view of the portfolio and some of the applications in the industrial internet sector.
Well, Michael, thanks. That was a very interesting discussion. And I'd like to thank TIBCO again for sponsoring today's IoTC podcast, and particularly our speaker today, Michael O'Connell, for his insight into today's topic. Well, this is Bill Voorhees. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on IoTC's next podcast. Have a great day.